in in assignment 7, I'm getting my assignments mixed up. I think that's the right one, right? The first half. In assignment 7, yeah. The actual linked list manipulations aren't all that complicated if you understand the specifications and what we're trying to do, I think. But then in assignment 8, they get a little bit messy. So basically, my idea is to try to do something a little more complex with linked lists today than what we did before. Any questions or comments so far? Okay, so what I had in mind is that we could start with the simple list class that we created before. I don't remember exactly how far we got with that during our meetings, but I know that the code was posted. And I want to turn that into an ordered list, which just adds a little bit of spice to the pointer manipulations that we're going to have to do. So let me go back and pull up our simple list class. Actually, what this is that I'm about to share. I think I'll just share the screen. So what this is that you're looking at over here is actually the simple list class, except I just went through and I changed everywhere I saw the word simple list, I changed it to ordered list. That makes sense? So now we just have to actually make the changes in the code that are going to make it so that the list is stored in ascending order. Everyone clear on what we're doing? So before, when we inserted something into the list, we just slapped it at the front, right? Now what we're going to do is when we insert something into the list, we're going to have to scoop down the list until we find where that node belongs and then insert it at that point. So just looking at, I wish I could make this bigger. I don't think I can. So hopefully you can see this. Just looking at our insert function here, that just inserts a node at the front of the list. So that's the main thing that's going to have to change. So here is a picture. You guys, I think you guys can see the whole picture, right? I can't see it because I have Zoom windows in the way, but let me try to get them moved. So here's an ordered list. And I just put this here so that we could have something to refer to as we're sort of talking through what our insert function is now going to have to look like. So the most important thing when you get to any sort of a halfway complex linked list operation is you have to think through what all of the special cases are, right? So the general case here would be there's lots of nodes in the list and the number I'm inserting is, say, 25. So it's going to go someplace in the middle. Then there's going to be a few other cases to consider, and I'm going to try to talk about these in order from most general or most common to most, I guess, rare or specific. So there's, I guess maybe I'll even enumerate them. There's the general case, which I just described. The next thing I would think about is lots of nodes inserting at end. Okay? Lots of nodes inserting at front. Okay? You might even have to think about if you're inserting it into the second position, but not usually. and not in this case. So I'm going to go with inserting at the front. And then another case would be you'd want to look at if there was just one node, inserting before it or after it. It's really two cases that I'm combining into one, but I'm going to go with that. And then there would be empty list, inserting something into an empty list. Okay. So I think what I'm going to do is we're going to write the code for the general case. We might be able to talk through this before we get to the code. Let me see how that goes. But basically, so in the general case, what we're going to have to do is we're going to create a cur pointer and make it equal to list. And then, whoops, copy. Okay, so that's, we're going to create a new pointer. There's going to be a local variable called cur pointer, and it's going to point to the same thing list is pointing at. And then we're just going to have a loop that goes until what? Anyone want to take a shot at what the while condition is going to be? Not in C++ necessarily, but just in English. No guesses? So go ahead, Patricia.
Per pointer will loop until it's null pointer?
Until it's null pointer, or what?
Or until the value, hold on, are we trying to insert it in the order where it's supposed to be? So
yes.
Like in between 20 and 30?
That's correct. So I guess I should put another variable up here. What it's called insert me.
Oh,
right? And that we said that's 25. So, right. I think you were on the right track. Basically, we're going to keep moving cur pointer down as long as it's not null pointer. And also as long as insert me is greater than the data. That makes sense? So if we do that, we're going to end up, in this particular example, if we do that, we're going to end up with the cur pointer pointing at what?
$20.
I think we're going to end up with cur pointer pointing at 30, right? Because when cur pointer is pointing at 20, insert me is still bigger than that, so we're going to bump it up again.
No, that's right.
Okay. That's a pretty important point. Everyone clear on that? Anyone want me to back up? Say it again. Okay. So I'm not sure if it's better. I mean, I'm kind of thinking that it's better to just talk about this first before working on the code. I'm hoping that doesn't make it too abstract, but we'll see how it goes. So next question is, anybody see a problem with that?
Well, you already have gone past the point where you need to insert.
Right. I've gone too far, right? And now that I've got a pointer pointing at the node that's going to come after the new node, there's no way for me to connect it up to the list. So what we're going to do, and we did this before with the delete function when we were talking about the simple list. What we need to do is we need to say the loop condition is going to be as long as cur pointer arrow next is not null pointer, and cur pointer arrow next is, I always have to think hard about whether it's greater than, as long as it's greater than cur pointer, I'm sorry, as long as cur pointer arrow next arrow data is less than insert me, keep moving, right? Even if the details there are a little sketchy, you get the point, right? We're going to keep going. Well, instead of just comparing cur pointer, we're going to be looking at cur pointer arrow next. Okay, so what we want then is we want cur pointer to end up pointing at the 20, and then we can create a new node, make the new node next point at the 30. Yes, right. And then make the 20's next point at the 25, the new node. Okay. Anybody want me to draw that out? I'm kind of thinking do the code first and then draw the picture, but because yeah, that's just the general case, right? I'm done with the general case now. Okay, so what about if we're inserting at the end? Will that same algorithm work, or will we need something different? And it's okay if you need to think about that for a couple minutes. I'll just give you some space. So if we use that same algorithm and the number that we're inserting is, say, 50, then what's going to happen is we're going to go and cur pointer is going to end up pointing at the 40, right? Because at that point, cur pointer arrow next will be null pointer, right? Turns out that if we do exactly the same thing there, it's going to work out, right? We're going to say the new node next pointer is going to point at whatever comes next after the 40, but that's null pointer. And then the new node's next pointer is going to point at the 40. Wait, no, I got that back. The 40's next pointer is going to point at the new node. All right, I'm starting to feel like maybe we should do some code on this, and then we'll worry about the other cases. Let's go over here to the code. I'm going to just delete those 2 lines. These 2 lines still apply, right? We're going to create a new node, and we're going to put the data in. And then I'm going to say, and so for right now, I'm just going to assume that it's always the general case. I'm going to write the code for that. And then after that, I will worry about the special cases. Hold on. Okay, so I may have to pause again in a minute, but we'll see how this goes. Everyone makes sense? Those two statements stay there no matter what the case is, whether it's the general case or one of the special cases. And I'm going to say, we said, create a new current node. So and make it point to the same thing that list is pointing at. Okay, so that gives us that, right? I suppose I should go ahead and draw the new node also. Okay, so that's the new node that I created with that line of code. The temp gets new node. And then the data that I'm putting in is a 25. And then I'm going to say Curve pointer gets list, so that's drawn accurately in this picture. Next thing I need to do is my while loop that moves curve pointer down, like we talked about a minute ago. So we said that was going to be while curve pointer arrow next is not equal to null pointer, and curve pointer arrow next. Actually, I prefer to say, and insert me is greater than curve pointer arrow next arrow data. Any questions about that? Okay, I mean, I think that's exactly what we just discussed, right? Okay, so looking at this, Mark, no, I mean, it just seems more intuitive to me that way. I've got a piece of data and I'm comparing it with what I'm looking at on the list, but I could see that could just be a personal thing, personal preference, I guess. Okay, the thing I want to point out, just sort of as a side note here, is that if you're looking at this, you should be thinking, okay, we're going to have to come back and work on that. Something is not right, because what if curve pointer is null pointer, right? But that's okay. We already know that we are just working on the general case here. We're assuming that there are plenty of nodes. So we're not going to worry about that yet, but we're going to have to come back to that. Okay. So while curve pointer arrow next is not null pointer, what we're going to do is we're going to just move curve pointer down. Okay. So in this general case, what that does is, okay, 25 is greater than 10. So I move curve pointer to here. 25 is greater than 20. So I move, wait, I'm sorry. We're comparing it with the curve pointer arrow next. So 25 is greater than curve pointer arrow next, which is 20. So I move curve pointer down to the 20. And then next time through the loop, 25 is no longer greater than curve pointer arrow next. So I stop. Okay. So that's where I end up after I finish this while loop. So now what I need to do is get that node inserted. So I'm going to say, oh, I forgot to, this is I called it temp, right? So here's temp. And temp is a pointer to this node. Okay, if I had to do it over again, I'd probably call it new node. Okay, so what we need to do is we need to make temp arrow next point at the 30. Right, we want it to do this. So that's going to be temp arrow next gets curve pointer arrow next. Everyone okay with that? This line of code results in this picture. And then we just need to make this node point down to the 25, right? So that's going to be curve pointer arrow next gets temp. Okay. Any questions about that? That's the general case. This will work for insertion. as long as there's plenty of nodes and we're inserting somewhere in the middle. Okay, so I'm going to gradually work my way towards the more restrictive cases. Okay, we were talking about if we have lots of nodes and we are inserting at the end, will this work? Okay, let's try it. Let's say that now we're going to insert the number 50. Okay, so, oh, look at that. I have insert. It's 50. It should have been 25. But now we're going to insert, we're going to make it a 50. So we enter the function insert with insert me equal to 50. We create a new node for the 50. We put it here. Wait, actually, let me do it this way. We put the 50 in there. That's the second line of code in the function is setting the data of the new node to whatever the parameter was. And now we're going to say curve pointer gets list. Oh, actually, temp points with that new node. Duh. Oop, that's not what I meant to do. Okay, did I lose anybody? Should I back up? Okay.
I think you're good.
All right. So now we enter the while loop and we keep moving curve pointer down. And where are we going to end up? We are going to end up with curve pointer pointing at the 40, right? Because at that point, curve pointer arrow next will be null pointer. So the arrows are starting to get a little funky, but hopefully that works okay for everybody. All right, so curve pointer is pointing at the 40 when we exit this while loop. So now we say temp arrow next gets curve pointer arrow next. Curve pointer arrow next is null pointer. So that's just saying temp arrow next gets null pointer. So I'm gonna put that in there. Everyone clear on that step? That was the temp arrow next gets curve pointer arrow next. And then curve pointer arrow next gets temp. Curve pointer arrow next instead of null pointer. Now it's going to point at the same thing that temp is pointing at. Oops. Bummer. Okay, so look at the list. That's actually the correct result, right? So it turns out that if we have lots of nodes and we're inserting at the end, that doesn't need to be a special case. It works using the algorithm for the general case. Okay. All right. Lots of nodes inserting at the front. So let's say now that we enter the function again, and now we have insert me is 5. Is our code going to work the way it is? Let's see what happens. Curve pointer gets list. While curve pointer arrow next is not equal to null pointer and insert me is greater than curve pointer arrow next arrow data. Well, curve pointer arrow, I'm sorry, insert me is not greater than curve pointer arrow next arrow data. So we never enter the while loop. And now where are we going to be putting that 5?
One more time. Could you repeat the question?
Yeah, I will, except I realized that I need to back up a little bit. I forgot to do these first 2 statements. Let me back up a little bit. Let's create the new node. And then let's do the second statement here, which is put the 5 in. Okay. And temp is pointing at that. Ooh, temp is pointing at that new node that we just created. Okay, so that's the result of the first 2 lines. And then I set curve pointer equal to list. I look at the condition of the while loop. It's false, so I never even enter the while loop. And so now my question is, where are we going to be inserting this new node that has a 5 in it? According to
between 10 and 20, right?
Right, in between the 10 and the 20, which is not correct, right? So our code does not work correctly if we're inserting something at the front of the list, which kind of makes sense, right? Because we never even look at what the first node contains. The very first thing we look at is curve pointer arrow next. So we are going to have to make a special case for lots of nodes inserting at the front. So let me just make an if out of that. If, so what's happening here is we're saying if if list arrow, I'm gonna stick with my pattern of you doing insert me first. If insert me, is less than list arrow data, that means we want to insert at the front, right? So that's just going to mean I've already got this picture here set up. I don't actually have a curve pointer at all, so let's ignore curve pointer. But I have this node set up. So what I need to do is I need to just say make temp pointer arrow next point at the same thing list is pointing at, right? Temp pointer arrow next points to the same thing that list is pointing at. So that's that. And then I need to say list points at the same thing that temp is pointing at. List gets temp. Oops. Which would say, make this point down here. Okay. Any questions about that special case? I think we just successfully inserted a node at the front of the list. And so what we would have over here would be else, do the general case, right? Indent all this. Okay. Oops. No, that's right. Okay. Any questions? We're still not done, right? We have a couple more special cases to look at. And it's a good thing because I see right here, if I'm looking at this, that should sort of be a red flag because I know right away, ooh, what if list is null pointer? That's not gonna be good, right? But I'm okay with that for now because I know I still have more special cases to take care of. Okay, number 4 here I have, if there's only one node in the list and I'm inserting before or after, turns out our algorithm works just fine for if there's only one item in the list.
Someone asked about line 17, if temp pointer should be
temp.
Yeah,
thank you. Actually, I should probably be calling it something completely different, but I guess I better be consistent. Okay. Okay, so yeah, if we've got just one item in the list, then if it goes before the item, it'll get handled by this situation here. insert me is less than list arrow data, and it'll insert it at the front successfully. If it goes after the first, or if insert me goes after the one node, then our general case handles it just fine because we just don't enter the while loop at all, and it works out. Okay, so all we have left is empty list. So what that means is, in my code, what that looks like is, well, I guess let's do the picture first. So now we're going to say, I don't want to erase all this. So just imagine that none of this is out here, right? And list is just null pointer. What we're going to need to do in that case is create our new node and make list point to it. And that's it, right? So let me get that into the code. If list equals null pointer, then what I'm going to do is I'm going to, so let's say I already created this new node, right? Actually, we're pretending none of this exists. So I'm going to actually go through the process of creating another new node. Okay, and because of this statement here, temp gets new node, temp arrow data gets insert me. The picture is going to look like this, right? I've got temp pointing at this new node. So all I need to do is just say list gets temp, and that will do this. Okay, anything else we need to take care of in that situation? We got one thing missing. One very important thing. We've got an empty cell. There's only one cell in my picture now that has nothing in it. What about this cell right here? What's going on with this cell?
You just have to set next to null pointer.
Yeah, we need to set next to null pointer. So I'm gonna. So that means in here it's going to be list arrow next gets null pointer. Okay, and then this is going to become an else if. So we've got if it's an empty list, do this. Else if we're inserting at the front of a list that has at least one node, do this. Otherwise, general case. Okay. Shall we try this out? I should have tested my code actually before we started running, modifying it. But let's try this. I guess I should have shown you the client code just as a reminder. Here's our client code. We just insert a bunch of numbers, print them out, and then we find a bunch of numbers, and then we delete a bunch of numbers. So let's try that. Actually, I forgot that typed in. Okay. Sorry, that's so small. Enter a number. I'll do 6, 8, 4, 7, 9, 2. Good enough. Okay, looks like it worked out okay. Got them all inserted in the correct order. Just for fun, I can try to find something. And the last item, or something's not there. Looks like everything's good, right? I won't worry about deleting. Okay. Any questions about insert? By the way, you're going to have to do, so I'm going to shift gears for a second and I'm going to talk about the assignment. But actually, so what I'm about to talk about is not about assignment 7, it's about assignment 8, which is the second half of the assignment. And that's where one of the things you're going to have to do is the big 3. So if you look at our ordered list class or the simple list class, whichever you prefer, you're going to find our clone function. And again, I would like to go back and change that to copy, but haven't had a chance yet. This is basically what you need to do in your copy function for your assignment 8. The only problem is you're going to have to add some code into here. And frankly, if I were you, I'd probably delete all of those comments. But anyway, you're going to have to add some code in here to make it so that the so if you haven't looked at the assignment, you'll have no idea what I'm talking about. So just put this in your toolbox, I guess. But the cursor and the precursor are going to have to point to the same nodes in the new copy of the list that the cursor and precursor pointers in the original list pointed to in that original list. So anyway, yeah, I realized too late that if you haven't looked at the assignment, that'll make absolutely no sense, but maybe you come back and listen to this after you've done assignment 7. Okay, let's look at these other functions and talk about if anything is going to be different now that we have an ordered list instead of an unordered list. And let's get rid of this. All right, I think that looks right. 5, 10, 20, 25, 30, 40, 50. So I'm going to just go down the functions here and we're going to talk about if anything else needs to change. Do we need to change our constructor? No, I don't think so. Do we need to, is anything going to change about how we print? No, still the same thing, right? We're just going to start at the first node and work our way down the list. Size, no change. What about find? Anything that we can, is there anything we can do differently in find? Let's look at this. And we did have 2 versions. I'm just going to stick with this one for now. Yeah, for our purposes of our discussion. But remember what the strategy was for find, right? We basically moved curve pointer down the list all of the way until we either found what we were looking for or we reached the end of the list. Is that going to be the same now that we have an ordered list, or is there going to be something different?
Should be the same, right?
Well, if I ask the question, will this function still work correctly? The answer is yes, this will still work correctly. Can we improve it now that the list is ordered? It would be hard to make it a binary search because we don't have a random access, right? Yeah, but there's one very simple change we can make that will make this more efficient. So if I call find, so if this is my list, and I call find with the argument being equal to, let's say, 22. Do I have to go all the way to the end of the list before I know that it's not there?
Oh yeah, Kaylin's right. You just have to go until you find a value bigger than the one you're looking for.
Right. So what's going to change in my find function to make it so that I take advantage of that efficiency?
Add something to the while loop, right? Because you want to check. Is that where you want to check?
Uh-huh.
Okay,
Right.
so you would just add and curve pointer arrow data is less than find.
Correct. Except it turns out we can just combine it with this, right? We could say,
Okay, yeah.
if curve pointer arrow data is less than find me instead of just not equal to, right? So if we get to something that's greater than find me, we stop. Or greater than or
Makes
equal to, we stop, right? So I just changed that to less than, and suddenly we don't have to go through the whole array. I'm sorry, the whole linked list, which obviously is a bigger win if the number we're looking for is not there, and it's on the small side, right? If we're looking for the number 7, and there's a million nodes in the linked list, this is going to be a pretty big win. Okay, any questions? Excuse me. Any questions about that change? Okay, I'm thinking about this. I think it's already in over to average. Even in the original case. And so that's kind of a trick question. I don't think the big O is going to change. It just depends on what it is you're looking for. So it might be a difference in like the worst case or the best case. But I mean, it actually only affects things when the number we're looking for isn't there, right? So it may not be that huge of a win, but anyway, I think that's correct. Let's look at the delete function. Anything going to change on the delete function?
You could do the same thing.
Yeah, it's just exactly the same situation. We're just going to say, and I'm looking at this and realizing that this is we had this discussion about which side to put the delete me on. And I said I liked it better on the left side, and now I'm doing it on the right side. But whatever, just keeping you guys on your toes. So this is, instead of going as long as it's not equal, I'm just going to go as long as it is less than. And that's pretty much it. I think that's the only thing that changes. Let me look at my notes and make sure I'm not forgetting anything. Oh yeah. Hold on. Do we need to revisit find? Yeah, we need to revisit find, actually. Sorry, I moved too quickly. So we have a little bit more going on here, actually, because when we get to this point, if curve pointer is not equal to null pointer, that doesn't mean we found it, right? So I'm going to have to say, if curve pointer is not equal to null pointer and curve pointer arrow data equals find me, right? So if we found it, and
would you still need the first condition?
conceptually, I could just say that. Okay, the problem there is, what if cur pointer actually is null pointer?
Then it won't be
Then
true.
then that would be an error. If cur pointer is equal to null pointer,
Oh,
I'm trying to dereference null pointer. It might be possible to switch, so I'm going to put that back.
okay.
I'm thinking it might be possible to simplify this by switching the if else, right? Like say if cur pointer is equal to null pointer. I don't think that's going to simplify it because we're still going to have, anyway, so this works. And it turns out that we're going to have to deal with something similar. Any questions about this before I go back down and finish up delete?
Makes sense.
Okay, so in delete, we're going to have kind of a similar thing, right? Now, if prev pointer arrow next equals, let's see, how did I change this? Hold on. Right, so it doesn't work very well with the if else in this order. So I'm going to basically do exactly what we did in find. I'm going to say, let me start by switching these. I'm going to say not equal to null pointer, and then I'm going to do those 4 lines. Everyone see what I just did? I just switched the if part with the else part, because it turns out that's going to make it simpler to update. So now, just because prev pointer arrow next is not equal to null pointer does not mean that we want to delete prev pointer arrow next. I need to also know that prev pointer arrow next arrow data is equal to delete me. Just the same thing that we did with the find function. And I think that's going to do it. Okay. So we try it out. So now if we were going to really test exhaustively, we would need to make sure that we're inserting at the front. We need to make sure we're inserting at the, I guess that's the only 2 cases, right? But we would want to confirm that it still works if we're inserting at the end and a few things like that. But let's give it a try. Oops. This is on line 68. I was afraid I would do that. I was using. Somewhere I have a load, there it is. Okay, let's try it again. Okay, so looks like it's inserting into an empty list correctly. Let's insert at the end of the list. Let's insert at the front of the list. Let's insert in the middle of the list. Let's insert at the front of the list again. And then let's put a 3 in just for fun. So there's my list, 1, 2, 3, 4, 5, 6. Find the first item, find the last item, find an item in the middle, find something that's not there. And then same with delete. Let's delete the first item. Let's delete the last item. Good enough. And then we can just check. This is checking the copy constructor and the assignment operator, but doubt if anything we did changes those, but we can just make sure. If we delete a 3, there's list 2. List is unchanged. Now we set list equal to list 2, so it's 2, 4, 5. Delete 4, so this is now 2, 5. List 2 is still 2, 4, 5. So that's all still good. Okay. Any questions about any of that?
Makes sense.
Okay. I think that I'm, unless you guys have any questions about anything, I'm gonna call it a day. And I really don't have much to talk about um, on Thursday, unless we just wanted to like do some more pointer manipulation stuff. But I think we've covered it pretty well. So maybe we'll meet and I'll just see if there's any questions or if you guys have a chance to take a look at the assignment and need some help going over the assignment. Actually, I guess, do you guys want to take a look at the assignment right now?
Yeah.
That would be great. Thank you.
Let's do
Sure.
that. Lists. Okay. So basically, there's lots of different ways to specify a list, right? In the textbook, the chapter that you'll read, he gives a list abstract data type. It's a little different from the list abstract data type or the list container class that's defined in C++ in the standard template library. And so basically what we're doing in assignment 7, it's a little different from what we've been doing. We've been kind of going right with the same abstract data type specifications that the textbook and the STL kind of are using. We're going to be doing something that's a list that's a completely different specification. And it's going to have sort of what I'm calling an internal iterator. So in assignment 1, we dealt with iterators, but they were external iterators, meaning you had the client programmer declared an iterator. And then if the client programmer wanted to do something with the iterator, they could move it down or whatever. But it was stored as an as a separate variable external to the object. What we're going to do here is we're going to set it up so that the iterator is stored internally to the object itself. So, I think that actually maybe the best thing to do to explain this class you're going to be writing is to look at some client code. So let's look at this. I was thinking I might try to make that a little bigger. All right, so the type that we're going to be defining is called sequence. So I declare a sequence variable, and so the sequence is just sort of another word for list, right? I'm going to insert the numbers 0 through 5 by calling s.insert. And what the insert function does, we'll see in a second, is it actually inserts before whatever the current item is. So with an external iterator, the iterator can point at any of the nodes in the container, right? Same thing is true with an internal iterator, but we just call it the current item. Whatever the internal iterator is pointing at, we call that the current item. The insert function always inserts before the current item. Okay, so if I insert the number 0, 1, 2, 3, 4, 5, and then, so I call s.start, that means make it so that the current item, the first item in the container is the current item. This is just a test that returns true if there is a current item. S.advance just means whatever the current item was, move it down to the next item in the sequence. So if the current, I don't say anything about that. And then what the advance function does is that if the current item is the last item in the sequence, and I say advance, then now there is no current item. And so that's why it works to say s.isItem, right? as the condition on our for loop. That means keep going until the s.advance function has advanced the iterator off the end of the, or past the last item in the container. And then s.current just gives us the actual data that's being stored at the current item. Okay. Understand why this program is going to print the numbers backward?
Makes sense to me.
Okay. Because as I said, the insert function inserts things in front of the current item. Oh, and I guess the other thing to explain about that is after you insert an item, that item you just inserted is the current item. Okay, so all of that is spelled out. I mean, I wanted to kind of give you the view from 30,000 feet first, but all of the details are spelled out here in the specifications. They're very detailed. Everything you need to know is in here in the specifications. Really important in this assignment, super important. One of the reasons I like this assignment, to separate the specification out from how you are going to implement it, right? This right here that we're looking at now, the implementation, the specification, always helps if you use the opposite word, could be implemented using an array, could be implemented using a vector, could be implemented using a dynamic array, could be implemented using a data structure we haven't talked about yet. We are choosing to implement it using a linked list. Okay, but this is just the specification. There's nothing in the specification about linked lists or nodes or next pointers or anything like that. Okay. Start, the first item in the sequence becomes the current item, but if the sequence is empty, then there is no current item. I'm not going to read through all of these. I'll let you guys do that on your own time, but do it at some point. Maybe if you could do it before Thursday, I'll give us something to talk about. Now we get down to the implementation. I think I labeled this. No, I didn't. Oh yeah, here's the label. Specification. Implementation. We will be using the following implementation of type sequence. So even though there's different ways you could do this, I'm requiring you to use this approach, right? You're going to have 5 data members. You're going to have a num items, which is going to be an int. You're going to have a head pointer, which is going to point at the first item in the sequence. A tail pointer, which is going to point at the last. I guess I'm going to use implementation language here. It's going to point at the last node in the linked list. Why would we want a tail pointer? I'll tell you why. It's going to be really helpful when we want to add something to the end of the list. Okay, so num items, head pointer, tail pointer. Cursor is going to be the name of our data member that points to the current item. So this is sort of our iterator, if you want to think about it that way. And then precursor is going to point to the item right before the current item. And hopefully we've done enough with linked lists now that you can see why we need a precursor, right? We need a precursor so that we could, if we need to, we can add something before the current item. Okay. So the precursor, let me just make, this is a point where you could go different ways with this. So I just picked one way and this is the way we're all going to go. Precursor points to no, if they're to null pointer, I should change that. Oh wow, I have null all the way through here. That should say null pointer. Precursor points to null pointer if there is no current item. Or to put it another way, points to null pointer whenever cursor points to null pointer. Okay, that's not necessarily always intuitive. You could say, well, if cursor points to null pointer, maybe precursor should be pointing at the last item in the sequence. That would be a legitimate way to do it. but that's not what we're going to do. Okay. I think that's all I'm going to say. Sorry, Kaylin, but I'm providing you with an insert function just because I want you to be able to get started on this and get a little, fairly far down the path before you get to the really hard stuff. And you can't really test anything if you can't insert things into the sequence. So here's my insert function, which I'm giving to you. So it turns out that assignment 7 is not too bad. Most of the functions are pretty, well, let me just say, as far as the pointer manipulation goes, they're pretty straightforward. Usually if students struggle, it's because they're struggling with understanding, what start is supposed to do and what advance is supposed to do. Once you understand that, it should be, the actual pointer manipulation shouldn't be too bad. All right, I think I'm done. Anybody want to ask a question about the assignment as I rapidly scroll up and down? Okay, so when you get started, I would say just make your default constructor, and then I don't know, what could you do? Just one. You could at least compile it with just your default constructor and your insert function. Make sure it compiles. Then you could write isItem and test isItem, and so your client program could insert something, and then you could call isItem. You could call current and print whatever it was you inserted. So say insert 7 and then cout s.current. And then insert a couple more things and then practice with your start function and your advance function. Okay. All right. So my plan is to at least meet on Thursday, and maybe I'll come up with, a great idea to use some of our time, or maybe I'll just make it a Q&A session, and if there's no questions, we'll have a short meeting. Okay. See you guys on Thursday.
Sounds good. Thanks.
All right. See you then.